Kent Seminar Series. Today we have two presentations of two ICT projects. The first one is from Assistant Professor Imran Hossain from Bradley University's Caterpillar College of Engineering and Technology. And he's going to be talking about unpaved roads in Illinois, their challenges and their opportunities. The floor is all yours, Professor Imran Hossain, so you can begin your presentation.
Thank you, Xavier. Good afternoon. Thank you, ICT, for giving me the opportunity to present at the Kent seminar. So today's topic is evaluating unpaved roads in Illinois, challenges and opportunities. This is a part of the project that we completed last year, which is methodology for evaluating steel-coated gravel and dirt roads. I was the PI for the project. Dr. Errol Tutumlar was the co-PI from U of I, and the TRP chair was Tim Peters from IDAT. At the beginning, I want to acknowledge the TRP committee and chair for giving their time and valuable feedback. I also want to thank ICT for their continuous support throughout the project. And obviously, this project would not be completed without the dedication of the undergraduate and graduate students from Bradley and U of I. So thank you to our students. Since I'll be talking about the challenges and the opportunities, and in between what innovative approach we have used to solve our challenges. So I break down my presentation into challenges and then innovative approach, and then the opportunities. We'll be talking about under the challenges, like what brings us to this project, and then what is the current practice can be used, and what is the advantages and disadvantages of those practices, and what innovative approach we consider in our project, and what is the future that we are looking into. So talking about the challenges, Illinois DOT breaks down its pavements into paved roads and unpaved roads. So according to the definition that the paved roads is an asphalt concrete surface or a cement concrete surface that is more than 1 inch thick, and the combined surface and the base thickness is more than 7 inches. On the other hand, the unpaved roads is asphalt concrete surface or a steel-coated road or gravel road or a simple dirt road, and the combined thickness of the surface and the base is less than 7 inch. So that was the pretty straightforward definition for the paved and the unpaved road. So we looked at IDA's 2015 data of various road classification, and we calculated the values, and we found that 58% of the IDA roads are unpaved roads, which is a pretty huge number. Again, the significance of the unpaved roads is like those are carrying like a heavy traffic, like from farm to market. So we have like a corn, soybean fields, all the trucks that is carrying the corn and soybean and any other products and goods, those are coming from the farm. Unpaved road, and those are also old. If you look at who is maintaining those unpaved roads, mostly county, township, and municipalities are actually maintaining and taking care of those unpaved roads. So if we see the percentage of 60% of the unpaved roads are maintaining by the township and municipalities. Just for a background, the county engineers, which is actually holding a engineering degree. On the other hand, the township's highway commissioners, who is in charge of maintaining the roads, highway commissioners are not necessarily have a technical background, but they are also elected person. And many of the highway commissioners, they are retiring and there's a new phase coming in. So not all of them are actually having the experience, the technical background to maintaining a road. So this is also a challenge in the highway commissioners front. So how do they actually evaluate their roads? So we did a survey throughout the state for both county and the townships, and we were surprised that identical county and townships, most of them, they do windshield inspection. So basically, windshield inspection is a county engineer or a highway commissioner is driving their truck, looking through their windshield and trying to subjectively understand whether a pavement is a good condition or a fair condition or a bad condition. On the other hand, there are a few of them are also doing the manual measurement, which is basically using an ASTM guideline to find out pavement condition index. There are very, very few which is doing a vehicle measurement, basically taking a automated data using a laser profiler or a walking profiler to find out the international roughness index. So you can see that most of the county engineers and also the highway commissioners, they are doing a subjective measurement, which is windshield inspection. Now, when they're doing the windshield inspection, obviously they are driving and they are doing their other work, and they can actually assess the pavement very frequently. So many of them, they actually evaluate their roads weekly and also monthly. So they know how the pavement is going on, so they can work into it if they need fixing a pothole or a gravel road. So that brings our objective of the project, that we want to develop a index system that is more objective and excuse me. And a highway commissioner and a county engineer can do a physical measurement of the distresses and use some standard procedure to find out a index for a particular road. And we are looking into a seal-coated road only because there is already developed index methodology for PCC pavement and asphalt concrete pavement. So we are going after the seal-coated road only. And then we use the cell phone app, which is relatively new now. We use that app to estimate the international roughness index for a seal-coated pavement. So that is the innovative approach we took into our project. So for the seal-coated road condition index, we did not reinvent the wheel. What we did, we use our existing standard, but we combined them and we make it usable for Illinois. So the method is, there is a standard table that a surveyor will go. It could be a county engineer or any staff from the office who has a technical knowledge of pavement distresses. So the surveyor will go to the pavement and then look at the distresses and categorize the distresses. So for an example, you can see the table over here. I have alligator cracking to longitudinal cracking, and how the cracking will be measured. So for an example, alligator cracking, it will be measured like a square feet. So basically taking his tape and measuring the area of the alligator cracking. And then not only that, they have to come up with a scaling, so the lower severity, medium severity, and higher severity. And then they're going to calculate the density. Density is basically the amount of that distresses divided by total area of the pavement. So they will come up with a percentage. And using that percentage and the severity level, using some graphs, those are already developed by the two standards that I'm showing here in a reference, using those graphs to find out the deduct value. And then do some calculation with the deduct value, use a simple equation to find out the rating. And the rating are given over here. that ranging from 0 to 100, 100 to 75 and excellent, and so on. So you can understand that it takes some technical knowledge, understanding which one is alligator cracking, which was in edge cracking, and which one is low severity, medium severity, and high severity. So what we did next, actually, we developed a library of images for the DOT to understand, okay, for a sill-coated road, which one is a low severe sill-coated road, which one is a medium severe sill-coated road, and which one is the high severe sill-coated road if we are considering an alligator cracking. And again, the definition is when we have a alligator cracking and they are not connected, that is a low severity, and when they are connected and they are breaking apart, that's a medium severity. When we have seen like exposed chips coming out due to the cracking, and that is the high severity. So we did that for various other types of cracking. So I'm showing you the example of the alligator cracking over here. The next one is the loose aggregate, and this is a severe distresses for a chip seal road, because the chips are embedded in the bitumen over the time due to the abrasion of the traffic. The chips comes out from the bitumen or the emulsion, and we see like the loose chips on the top of the pavement. So that you can see the third one, it looks like more of like a gravel road instead of a chip seal road. So we see that also in sill-coated road. And the next one is the bleeding. And again, we developed that library for the IDAR, that, okay, which one is the low severity bleeding versus a high severity bleeding. So looking at the picture, a highway commissioner or can actually understand which type of severity they are finding out in their pavement. And another one is for the longitudinal and the transverse cracking, even though the mechanics behind the longitudinal and transverse cracking is different. But we don't want to go into that complexity. We just want to make sure, okay, there is a longitudinal cracking and there is a transverse cracking. And when we measure the thickness of the, or the width of the crack, we can find out whether it's a low severe or a high severe crack or medium severe crack. So using our own table and our own library, what we did, we went back and we did find out index for few of the sill-coated road, and we cross-check with our value with our TRP committee member, which consists of several highway commissioners and county engineers. So we did that and cross-check with them. So for an example, this road, we use our library and we use our chart to find out the SCRCI, and then we said, okay, this is a poor condition pavement with a grade of 23. And we said, okay, what do you think? Do you think this is a poor condition sill-coated road? And we show our pictures, and they said, yes, it's a poor condition road. So definitely we need to fix it. So again, considering the limitations of that, the manual method is time consuming. It is also labor intensive, and also if some of the chip seal roads has very high volume of traffic as well. So we actually had to do a lane closer to take the data. So there are various limitations in this method. So how can we actually improve our data collection procedure? So in part of the innovative approach, what we did, we used cell phone apps to measure the international roughness index. Again, we did not develop the app. What we did, we used the already developed professionally used cell phone apps that we can either buy it or take a subscription from the marketplace. So we use three different types of apps. So the one is RoadRoid, Road Bump, and Total Pave. And all those three apps are available right now only for the Android-based cell phones. So basically, it is not available for the iPhone or iOS devices. And all those three apps, what they do, they actually use the sensor inside the cell phone that records the vibration of the vehicle when it is driving. and use some equations to calculate or estimate the IRI. So fundamental is the same as the IRI measurement for any high-end devices using the vibration. So what we did for our project, we used one cell phone, which is Android-based, Samsung S3. We used 4 different types of mounts to check the variability of our data. And then we establish a speed range which speed range gives us a consistent data. And then we use both sedan car and truck while collecting the data. And then we also compared the cell phone measured IRI with high-speed inertial profiler and walking profiler. So we want to make sure that how they are varying compared to the industry practice devices. So this is the laser profiler used by IDOT. So in the middle picture, there is a laser source that actually shoots a laser beam onto the pavement. And that laser beam actually, when the truck is driving, the laser beam goes ups and downs depending on there is the undulation, cracks in the pavement, and it accumulates all the undulation value or the vertical difference value divided by the total length of the measured pavement, and that is the IRI value. And the data is collected automatically into a laptop, so we can get the data right away after we collect the data. So what we did at the first trial, we used a seal-coated pavement, and we set up our, actually the laser profile is already set up into a truck, and we drove starting from 40 kilometers per hour to until 90 kilometers per hour. And the first value is for the lower speed, and the next one is the higher, and so on. And we also have our cell phone mount onto the truck to measure the IRI value as well. Now, what we see over here for the laser profiler, as expected, the value is very consistent. It does not change with the speed of the truck, and that is what we are expecting. But if you look at the road droid data for the car and the truck, we can see that the value is actually increasing with the speed, and that is also for the truck. So we kind of understand that probably due to the higher speed, we're actually introducing some vibration from the car and the truck. So we probably need to reduce our speed range. However, the road bump works differently. It started with a very high value, and then it is showing a lower value. So we kind of like a surprised also what is going on here. So we need to take definitely more data over here. So what we did, the next trial we did at the Springfield, and this is the site that IDOT used for their calibration of the laser profiler. It has a smoother lane and a rougher lane, and you can see over here that there is a mark that shows where to drive the truck or the vehicle. So there's a lane marking over here. So we did for the laser profiler, we did for the road droid and the road bump. And what we understand from this table that, again, we want to make sure that the road droid and the road bump is separating a smoother lane and a rougher lane. Basically, for the smoother lane, it should show a lower value. For the rougher lane, it should show a higher value. So you can see over here for the laser profile, it is 1.5 and 1.8. So comparing the value, higher value for the rough lane. For the road droid, again, 1.3 and 1.4, again, showing a higher value for the rough lane. For the road bump, 1.7 and 1.7 and 2.4, also showing a higher value for the rough lane. So we can actually assure that, okay, at least they sense the smooth surface and the rough surface. Next, we did another trial with the, this is a taxiway in Rantol Airport, and we compare our road droid and road bump data with the handheld laser profiler. So again, it has a rough lane and a smooth lane, but also you can see the dot line over here. This is the line that we use to drive our car and also the handheld device. Again, for the walking profiler, it can definitely sense the smooth lane and the rough lane, 1.8 and 4.7. On the other hand, for the road droid, the average is same, 1.3 and 1.3. For the road bump, it senses 2.7 and 3.7. So it shows a more value for the rough lane. However, you can see that for the road droid, the value is more consistent compared to the road bump for both smooth lane and the rough lane. So there are some variabilities we surely see in the data. So the next we did a test on the 4 different mounts where you have a short arm mount and then long arm mount, windshield, and then the air vent, and then we have the dashboard, the conventional dashboard mount. And then we did test it for all 3, and you can see over here now we change our speed from 30 to 50 kilometers per hour. So again, there are some consistent results, and also some results are like a very high, and we kind of sense that due to the airflow of the air conditioning, the air vent mount sometimes moves high, so we need to take care of that. What we have seen here that for the windshield mount, sometimes it happens that the phone dropped from the windshield because of the vibration. Comparing all those 4, dashboard mount was more consistent. It was not actually falling off from the dashboard while we were taking the data. So we did that for many roads over here. So the next one is for the Fulton County. We did for all the 4 mounts over here. And then another data over here, and we have seen that there are some mounts that shows a consistent result, and some mounts are not showing consistent results. But we also have to think about the convenience of taking the data. If the mount is falling off from the windshield while we're taking the data, that is not convenient. So we actually rule out the windshield mount from our next data collection. So we use the dashboard mount. So after narrowing down our speed range and the mount, we then use all the 3 types of cell phone apps to collect the data. And you can see over here the road droid, except for the first data over here, and I'm going to talk about the first data pretty soon, that for the road droid and the total pave, they are more consistent, but also like for the road bump, it is always showing a very high value. So what is happening for the E1850 North data? When you took the data with the road droid, it was like a new seal-coated road. And again, new seal-coated road usually rough road because the chips was not set yet into the binder. And we used the total pave after 1 year. So we took the data in 2017 and using the road droid, and the total pave we used in 2018. So by that time, the road was smooth. So we got more like a lower value for the total pave. So we summarize that we can get a consistent data if we drive a sedan car or a truck in 30 to 50 kilometers per hour. Road droid and total pave, they are more consistent and comparable with each other, and road bump definitely giving us a overestimating value. And dashboard mount is more consistent because it is not falling off from the dashboard while we are driving. So we use these 3 summary for our next result. So the opportunities now that is coming in the future, we started collecting data for the counties. Right now we are using road droid and the dashboard mount, and we're using 2 cell phones. So for the Peoria County, we used that data collection for the last year, And we get some promising result, very good result for both cell phones and the road droid we're using now. And we are doing the same for 80 more data this year, this summer. And I know there are 2 more counties who also showed interest using the apps and the cell phone measurement to take their IRI data for the whole network. We still use the manual data, but I think there is opportunities in the future to use the app and take a network level data. But for more project level data, we still need to use our manual method. So I want to end my presentation here. So I'm open for any question, and thank you very much.
Thank you, Imran. Anybody that has any question can hop in now or raise your hand. I think I do have a question for you, Professor Imran. I was wondering about the mounts and how much variability they're giving to the measurements. Can you elaborate more on that, and why did you choose the dash mount finally?
So when we look at the mount, let me go back to the slides quickly. Okay. So there is some consistency and inconsistency in the mount, but we also look at the convenience, because when we're using the short arm and the long arm mount, we have observed that sometimes the mount is falling off when we're taking the data. Or on the other hand, for the ear vent, sometimes it's too hot, and students who are like increasing the airflow of the air conditioning, and we actually introduce more vibration in the ear vent mount. But on the other hand, the dashboard is more consistent when we compare with all 4. So that's why later on we said, okay, let's stick with the dashboard mount. This is sturdy and it is not falling off. It is not vibrating too much. So let's pick that and let's use that for the next data collection.
Thank you. Does anybody else have a question? Okay, if that's not the case, I think we can go now with the next speaker. We have another ICT project being presented now. The presenter is PS Sriraj, and we have him online now. So I'm gonna ask Professor Imran if you can stop sharing your screen so the next speaker can share his.
Thank you, Javier. Everyone. It's great to see such a robust crowd, albeit virtually, for these talks. It's greatly appreciated, and I'm going to try to do this. And I know Noel will help me if I stumble, so I pulled. So we'll see how adept I can be in getting this off the ground. Just bear with me for a second. I'm just looking for that presentation. Oh, there it is. I think you're seeing the thank you slide first.
Correct.
And that's not a bad way to start. So this particular project and the subsequent paper that we presented to the TRB audience, the Transportation Research Board, is what I'm going to share with you today. I'll try to get through it as quickly as I can so that we can have some discussion if there needs to be a discussion. It's about project itself, funded by CT, of course, and the topic is to study the inland waterways and ports in the Illinois system and see if there can be a recommendation that can be made about performance measures. So that was the overall objective of our work. We are still working on it. We are hoping to wrap it up in the next couple months. But this paper that I'm going to talk about is focusing on the first half of what we did in terms of our literature review and the survey of various state entities and what we found therein and the preliminary recommendation for what the database should look like. This, of course, was led by Nahid Parvez Farazi, who's our PhD student in civil and materials engineering at UIC. Dr. Bozo, listed here, is my co-PI, an associate professor in civil engineering again. The background and the motivation, this is essentially a snapshot of the strength of the inland waterway system in Illinois. In the US, it's a very, very essential link in the supply chain as it pertains to trade and commerce. And it for about 600 million tons of cargo each year, accounting for about 14% of the total domestic freight. With that level of importance, we assume that every state would have a very formal mechanism for overseeing this. Every state is charged with providing the oversight and for developing a comprehensive performance measurement system for the inland waterways in their respective states and the waterways that they have jurisdiction over. And how that comes about in practice is what we were curious to know about. Our task, as I mentioned, is to develop a set of performance measures to track the relevant data and how we can then proceed from that point on. In order to help us to shepherd this process along, we engaged in 3 distinct clusters. One was to summarize the state of the research. 2 was to develop and recommend a systematic approach for performance and their tracking. And then if there are any benefits that will accrue because of this structured plan, that is also something that we are curious to know and document. Of course, we are very thankful to the ICT as an entity and to all the individuals therein who have been very, very supportive, not just financially, but also in keeping me in check. And so I have to give a shout out to various people who have sent numerous emails to make sure things are in order. That's the ICT project number for your reference. The map on the right gives you a snapshot of the inland waterway system in the state of Illinois with its various elements. The advisors from IDOT, 2 of them are listed here. It's not the entirety of the TRP, but I just wanted to acknowledge the ones that we work on almost on a day-to-day basis with. Clayton Stambaugh and BJ Murray from IDOT are our main points of contacts. At UIC, our other team members, apart from the 2 that were listed in the previous slide, Lisa Dirks, who's a senior research specialist at the Transportation Center. Elliot Lewis is a graduate student, and Jean-Paul Manzanares is also a graduate student at the Transportation Center at UIC. That's the backdrop. The outline for this talk, we'll navigate this as I go through each of these slides, but that gives you a sense of what I'm trying to convey here. The inland waterway system, I talked about it in big picture terms, and this is more specificity here in this slide. Nationwide accounts for about 36,000 miles of the waterways. Commercially used for about 1/3 of it is being used for commercial navigability purposes. 38 states are directly linked by these navigable waterways and are served by them. The elements of the waterway system, locks are the essential elements, 239 lock chambers in 193 lock sites, with the largest system being the Mississippi River system that touches us. And then there are other various systems, Columbia Snake River system, Gulf intracoastal waterways, variety of other things that you can also see on the map on the right. Before getting too much into the weeds here, I also want to make sure that what are the elements of the inland waterway system that are essential. And this picture really nicely encapsulates all of the functional components. We have two, and I don't know whether you can follow my cursor. If you're not able to, let me know. I'll try to see if there is another mechanism to sharing my cursor. But if you are able to, then I'm
We can
pointing to
see
the
it.
water. Excuse me?
We can see it perfectly.
Perfect. All right. So you have the water side and the land side division that is essentially segmenting the components. On the water side, you have the vessels, their maneuverability, the locks and dams that control the flow, and then the cargo loading and unloading, at least a portion of it on the water side as they approach the ports. And then on the land side, you have the port facilities, which also overlap into the cargo loading and unloading. And you have the terminal operations and the access to road and rail and pipelines from where they get to be moved on surface to various other destinations in the lower around the country for that matter. So this line, the vertical line that you're seeing, the divide between the water side and land side is where the intermodal activity happens. And that also could be a way to delineate where the responsibilities end and start for various entities that are part of the inland waterway system. So where do the port authorities responsibility end? Where does the marine entities responsibility begins? How does that reflect on how various activities are tracked? How are they documented? All of those will play a part in how, what kinds of elements we can make a recommendation about. In order to give us a better sense of understanding, we wanted to make sure we studied these components based on what the literature has talked about, what some of the agencies and administrative entities have reflected on, and the quick recap, the status of the inland waterway system components. I would like to draw your attention to the highlighted areas and the ones in the blue. The impact of discrepancies as it pertains to resiliency and risk analysis and their interdependency with the waterway infrastructure. As far as safety and security are concerned, there's legitimate issues pertaining to theft, pertaining to spills that in the water system, and any issues that are either pertaining to the commodities themselves or to human beings. There's a variety of things that are in the safety and security aspect. There's a lot of questions about the sustainability. This also ties in funding issue. There should be, whether there exists, a more traffic flow forecasting mechanism, and how well the routing and other associated details are subject to any optimization principles, and or is it just a by the seat of the pants, if you will. So those are all important questions that need to be answered. And especially when you look at the ports and harbors, what we saw as it pertained to the literature was there were two segmentations of the performance measures, one pertaining to the financial component, the other pertaining to the operational. The operational is pertaining to all the traffic that comes in and other associated details. Financial is how do they make do with the limited resources that they have. There are some environmental performance measures, but not very well documented. This third bullet point, the truck traffic and truck turnover time, is the one that is cited most in the literature. And we were also very curious as to whether that reflects itself when we go around talking to the port districts as we are doing now. The locks and dams, which are under the control of the Army Corps, are also in need of financial boost, as we found out in the literature. Aging and deteriorating infrastructure. There is a desperate cry for funding for maintenance of these facilities. There could always be a lot of issues pertaining to whether the structural design can be improved upon, Can there be uniformity in terms of the vessel characteristics? Can there be any standards that can be brought into this domain? How susceptible are these to weather issues? And how does that tie into any resiliency of these? Are also much needed thoughts that are um, discussed in the literature. There are no immediate solutions that have been bandied up, at least they are acknowledged. Administration and government needs to focus on. That brings us to the feds. And the federal role is very, very high level role. So the US Army Corps I touched upon a couple of slides ago, pertaining to their role as it pertains to the locks and dams. Army Corps is in charge of constructing and maintaining navigation channels and harbors, and also in regulating the water levels on inland waterways. So those are the twin functionalities that they have on paper. And they also have another functional element, which we'll get to later on in the presentation. But the Coast Guard, their duty is well understood: safety, security, and stewardship of the entire waterway system in the nation, not just the inland waterways. And MARAD, of course, is the governmental arm, the administrative arm. It supports ships and shipping operations, ports and vessel operations, and they strive to achieve multimodal integration. Now, their role is much akin to what you can pertaining to FTA on the transit side, because they are very, very superficially involved in the day-to-day activities, as opposed to something like FHWA or FRA, which have more in-depth understanding and involvement with the systematic components. Other efforts at the federal level in terms of the performance measurement systems. There's a committee, the national level US Committee on Marine Transportation System, that has been involved in understanding the importance of performance measures. The Army Corps itself has identified 17 major maritime performance measures, and also has put together the Waterborne Commerce Statistics Center, that is a dissemination source for data and performance measures. MARAD, in their own way, have identified performance measures to track marine maritime, right? Container terminal productivity. And then also involved in influencing vessel calls at US ports and terminal facilities. As you can see, there is a lot of players that are involved, but apart from the Army Corps, there's not been any very substantive directionality that has been provided as it pertains to performance measures. So it's a very often overlooked, underappreciated aspect of what the highway capacity manual. You have all the metrics that are used to understand congestion, safety. On the waterway side, there's a lack of that sense of understanding, be it by design or by chance. A lot of it points back to the funding issues. FHWA, for its part, as it pertained to the land side thing, freight performance primer proposed several PMs for the waterways, performance measures for the waterways. And so those are all things that we found that have been discussed. It still doesn't showcase the ideal database or the ideal set of performance measures that can be used. So when we got this big picture understanding of the federal involvement, we started doing a scan of state level practices. So we undertook, I mentioned at the outset, there are 38 states that are touched by the navigable waterways in the country. We looked at the state freight plans, the maritime freight plan or strategy that if it existed, any periodical performance review report, and other reports that were pertinent to the maritime and inland waterways in respective states. So this was a web search, calling people and finding out if they can point us to any documentation. And that's the That's the as of last year, 44 states had published a state freight plan, 44 of the 50, and then that includes the 38 that we were focusing on. State freight plan is the broader freight plan, not just for the waterway system. This is including over the road and other mechanisms. 32 states were selected out of this 44 for review based on the following three criteria: availability of an state freight plan, whether they had a maritime on inland waterway freight functionality. So out of the 38 that we had identified that were served by the waterways, 32 were selected, and also based on the annual. So did they handle enough tonnage for us to look at it critically? Those were the criteria that we employed in identifying the 32 states. And in order to further dive into these states and their documentation, we asked four questions. Do the states have any specific freight related performance measures? Do they have any specific maritime performance measures? How many of those performance measures in the maritime bucket are discussed or reported? And are these performance measures included in the state freight plan or in the maritime plan for that particular state? Um, as you can see, discussed as it pertained to the documentation or in the performance report card, if they have a performance report card, those were things that we were taking account into. States is the state's maritime plan embedded in the state. So the nexus between the freight plan and the maritime plan is also something we were very curious to find out, because that could help IDOT, who's the primary beneficiary of our work, to incorporate any such best practice into what they are getting started to doing. Does the state have any dedicated plan for its maritime freight transportation? So all of the questions are very, very specifically addressed and look in understanding how integrated the maritime plan, if it existed, with the freight plan for the state. If there was a maritime plan, were there any performance measures that were included? So this is a quick recap of that scan. So we had 27 states that had a performance measure for freight in general in their state freight plans. 12 states discussed the inland waterway performance measures. Every state's maritime and inland waterway plan is embedded. So whichever state had a maritime plan, they managed to fuse it with the state's freight plan. And 6 states have supplemented the inland waterway strategic planning effort with the freestanding planning document. So they went over and above and beyond their original goal of fusing it with so they had a very specific individual maritime plan. More results from that scan. The status as it pertained to the various states. So here you have a graph, number of performance measures on the vertical axis, and the states we had identified as having done something in terms of their activity in the maritime sphere. So here you have, those are the 12 states that discussed the maritime performance measures. 7 states that reported them in their performance report card. So you have the maritime inland waterway performance measures discussed in the blue bar. They are reported in the green bar. Those are the ones that you're seeing those arrows pointing to. And then the domestic waterborne traffic in millions. So you have this right axis, waterborne traffic in millions, and these crooked lines are representing the impact or the magnitude of those waterborne traffic. And so the one overall takeaway from this is there is no correlation, absolutely none, between
I think we lost Sriraj. Is anybody else hearing him?
No, no, I'm not.
Hear either. I can't hear.
Yeah, I think we lost the speaker. I'm gonna give him some time to see if he can reboot and reconnect again.
it's a mixed bag. Of the 12 states, only 5 were using cargo tonnage. 3 were using the tons of freight, and then, of course, safety measures of inland waterway crashes and incidents. Only a couple of states that were using it. Other highly discussed issues were maritime plans. They talked about delays in locks, the dredging that is needed of channels to maintain navigable depth for their barges and ships. Smooth and efficient multimodal integration is an aspect that they strive for, especially as it pertains to the transition between the water side and the land side components. So loading, unloading, and then transporting from thereof is something that has been an issue. Reliability of the gates in the locks and gates, the truck turn time is also a major issue that was indicated. How does it reflect when we go outside the boundaries of this country? And then we found this particular document that was very, very useful for us in getting a snapshot of what is happening around the world. The Permanent International Association of Navigation Congress came out with a report in 2011 that identified 35 performance measures, mainly focusing on European waterways. And it was an EU-funded project on Nevada Duo, focused on performance measure as it pertained to the Danube River in 2012. Other mechanisms, the UK has developed a comprehensive maritime strategic plan called Maritime 2050. And then the City of London has its own freight plan that outlines policies regarding inland waterway freight transportation. So there are enough instances of this happening around the world. Um, and then then the question for us, as we've looked at the states, we've looked at other countries, how do we categorize the performance measures? And that's a major challenge for us. We have to identify the system deficiency, identify the performance areas that need improvement, categorize the infrastructure assets, and then ensure the selected performance measures allow for efficient allocation of resources, right? The allocation of resources will drive most of this. The common practice based on that is being adopted now is strategic goals of freight modes. That's essentially what most entities try to do. And so we took a preliminary look at how we can segment this, the water side, land side components. You have the navigation channel, locks and dams, intermodal integration, and ports and harbors on the land side. Then the 5 classes of clustering: safety, security, maintenance, preservation, system resiliency, mobility, congestion and reliability, environmental stewardship. On top of those 5, we added the economic development, information and communication technology, and customer service also as ways in which we can identify performance measures. What are the purported benefits of these performance measurement systems? DOTs can benefit by prioritizing projects and use the available funding, if there are any funds available, in an efficient manner. They can also help in state DOTs drawing up a complete and comprehensive strategic transportation plan, because every state produces a transportation plan once every few years. The inclusion of the inland waterway system will only make it more robust and present a more complete picture. The proper mandate for so you cannot necessarily go to the feds for asking for funding or to the state to ask for funding unless you can document that your system is in dire need of funding. And then one of the side benefits of a performance measurement system is you can document and outline the inefficiencies and the necessity to fund the system so that those can be overcome. And the inefficiencies can also be reduced, and the cost overruns can also be controlled with a funding model that is doing justice to the needs. So we have also done interviews with state DOTs that reflect more or less on the same issue. The state DOTs are staffing at least a half full-time equivalent or one at the most in terms of dedicated personnel for looking at the inland waterway system. There is hardly any dedicated funding for the inland waterway system, which is not any dissimilar than what we have in Illinois. At least with the recent capital bill that was passed, there seems to be an infusion of funding, at least a one-time infusion of funding into improving the inland waterway system. So those are all good aspects that I would like to highlight. At the same time, the water freight performance measurement system is far from being mature as it pertains to the inland waterways. The limitations are the funding that I talked about. Data are just not available. Currently, we are doing a survey and also doing interviews with port districts and carriers. There's not a lot of understanding of the importance of data, or there is not a lot of resources available to catalog the data and use them for tracking performance. So the onus falls back onto the states in order to pay attention to the needs and challenges, because if not for the inland waterway system, the transporting of goods may assume more criticality, because then you are going to be dependent on a couple of different modes. States should draw insight from existing research and practice. That's what we are doing currently in assisting ICT and the IDOT folks. It should be used to build a proper performance enhancing model that will address the overall improvement of the system. And I know I rushed through all of this. This is definitely not the entirety of our project, but this is what we presented during TRB. There is a subsequent presentation that we made to the technical review panel, and that's also available that we can share with you. But I'd be happy to answer any questions. I know it was disjointed because of the disruption on my end. Apologize for that, and I'm happy to answer any questions.
Thank you, Sriraj. We are currently over time, but if we have a quick question, maybe we can take one question. Do we have a question from anybody? So if not, you can always email Sriraj at that email that he's presenting on screen. And I would like to thank both of the speakers, Sriraj and Imran, for presenting to us today the ICT projects that they have been developing. And thank you everybody for joining, and see you guys next week.
And then thank you for inviting us. We'd be happy to share the final results of our project as and when we are completing this.
Thank you, Sriraj.